Our last but not least speaker is Dr. Luke Lee. He will give us a presentation on LOGAN diffusion cell apparatus for IVPT and IVRT. Dr. Lee is the CEO, President, Chief Designing Engineer of LOGAN Instrument Corporation. He has over 30 years of experience in transdermal diffusion cell apparatus and is the proud owner of over 70 design patents. Dr. Lee, the floor is yours.
Good morning, everybody. Can everybody hear me well?
Yes.
Oh, very good. Okay. First, I would like to thank you for the opportunity that Sam, Dr. Wang offered to us to join this workshop. And we take this opportunity to share our diffusion technology to everybody. Okay, here it goes. To make it easier, we break our diffusion apparatus into 3 sections. So here we go. The first section I want to talk about is about the dry heat system. So you can see this dry heat cell is designed by a genius engineer. It's being used all worldwide over 50 years. It's a wonderful design. So what we did is we basic on this cell concept, we design cell, what we call dry heat cell. So you are able to run 12 cells or 24 cells at the same time. So we produced this product in the early 90s, and we sell many of them. And later on, we got a lot of feedback from the customer. They say, well, this is wonderful cell. But sometimes, because it's made of glass, it's very easy to break. And I always have a bubble problem under the membrane. And some people reply to us, they say, well, it's difficult to sample. I want to remove all the media in the cell, but it's difficult to remove that. Can you do something to make it easier? So we got all the feedback. So we designed new generation of the bubble cell. So what we call a bubble cell, because the cell have no bubbles. So what we did is we take the same concept. What we did is we moved the 45-degree sampling port to the bottom. So then we add the vent on the top. So what we do is when we fill the sample, we fill from the top, go into the cell, and all the air bubble will go out from the side. We tilt the cell. So when you take the sample out, the air will go in to the cell, and you would not create any section to the membrane. Then all the media or the sample will automatically go out. So here's demo. So you can see the cell is tilted. So the media fill from the bottom, and it goes to the top. And then you can see all the bubble will automatically go out from the vent. So we can ensure there's no bubble under the membrane for all the cell. So at the same, we do it reverse. So we tilt the cell, we take the sample from the bottom. So there will be no vacuum created on the membrane. So the next one is we sell this one for a long time. Then people come back to ask us, he said, well, this is a great design, but I still have to hold the cell in my hand. I have to tilt it. Is there any way you can make it auto tilt? So what we did is we designed a system with a motorized tilting device. So what we can do is we can do 6 cells at the same time. We can fill 6 cells at the same time. So here's the demo. For the demonstration, we only do 1 cell. So all the cells tilts. Then we fill the media into the cell. So you can see the bubble goes out on the top. Here you come. Okay, so after that, we can press the switch, you will go back to test position. So that's what we have called semi-automated system. So on this picture, you can see we have 6 syringes. You can fill all 6 cells at the same time. You press all 6 syringes together, you fill up the cell, and purge out all the bubbles. So for the cell design, we change the value by different size of a stir bar. And we also change the office size by different size of gasket. So from here, you can see our cell is a standard with a 12 ml inside. So by using we have different size stir bar, like 1, 3, 5, 7, 9. So let's say if you have 12 ml value, then you drop a 9 ml stir bar inside, automatically become 3 ml. So that's how we do. We have used one standard cell, we change the stir bar to change the values in the cell. So to protect the formulation during the test, and we have a cap. We designed a cap fit over the donor. There are two types. One is with a screw thread. We have a loose thread. So when you screw the pressure, the air will leak out from the thread, instead keep the pressure to the membrane. And we also have another type. It just is a cover, very easy to fit over the donor to make sure there's no dust or no evaporation from the formulation. So we saw many systems. Later on, people come back to tell us, he said, well, my sampling time is every 2 hours. I have to continue 48 hours to take sample. So is there any way you can make it simpler for us? So what we do is we design an automated system. So we use a semi-automated system. We add a system controller, we add a syringe pump, and we add the collector. So we build up from the module, from the one system, 6-cell console, we can all the way go up to 24 cells. Okay, so but when you do the automated sampling, we also can add the syringe on the sampling port for the manual sampling. So for the staggered sampling, so you can use a manual syringe to take the sample until the time, long period of time, the sampling time is over, then you can do the automated sampling system take over. So the next one, we sell this system, then people come back to us, they say, that's a great system, but I want to know the cell temperature. I want to know what's the receptor temperature. I want to know what's the membrane temperature. So what we do is we design another system, which was a sensor in the cell, and then we have a sensor for the membrane. So that's how you work. So we have an individual sensor in the cell. That each cell's temperature is displayed on the display on the color display screen, and in this case we show it 37 degrees. But the temperature setting can be anywhere from 25 to 45 degrees. Then the speed we can control anywhere from 100 to 100 RPM. So if during the run the temperatures run off or speed run off, there's an alarm system will automatically kick off and tells you something wrong with the system. And the people can come here to fix, or they know what's wrong during the test. So for the skin, to mount the skin, what we do is on the cell surface, we design the groove. So all you have to do is lay the skin flat and use your finger, press the skin over the groove area. So this part of the skin will set into the groove. So make it very stretch very easily and keep the skin flat. So during the test, there's a gasket, there's a donor, the skin is not going anywhere. So the same system, we can have a temperature display, the cell temperature display, and then we have a membrane temperature display on the top. So during the test, the program will constantly print out the data, what's the surface temperature, which is membrane temperature, and then what's the cell temperature, constantly report. So then this system, we can build out all the way to 24 cell system. So here's the demo of the system.
System 918-12. Step 1. Turn on System 918. Create method where return to cell or go to waste may be selected. Select method previously created. Set temperature and select stirring. Step 2. Prepare. Filling the cells to about 90% of the total volume. Step 3. Load sample. Load sample onto membrane or skin, then click Fill until extra media comes out of the exiting port. Step 4. Click Run. Step 5. Sampling. The sampling probes move to waste. Priming starts.
So the priming is to get rid of the depth value in the line. Then we take full stroke of the sample in the cell and deposit a waste section to clean the line, then deposit into the tube.
Sampling probes move to designated row to pump the samples into the test tubes or HPLC vials. Step 6. Refill media.
So each time,
The cells tilt up while the syringe pumps take fresh media from the media reservoir and refill the lost volume. The cells go back to the vertical position after media replacement is completed. Step 7. Waiting for the next time point. Step 8. Cleaning. Set the cleaning procedures and click Cleaning. Logan, since 1990.
so the cleaning method can be set before the test. So after the test is over, you will automatically start the cleaning. So the next system is a robotic system, because we saw a lot of system, and then some customer come back, some user come back, they tell us, they say, my sample is a biohazard, so they don't want to in contact with human. Is there any way you have a robot to do that? So what we did is we come a robotic system. So what the robotic system have 4 sets of syringe. The above set syringe is with a 1 ml syringe for take samples. The lower one is the control the media to remove or refill the media. So the cell is like this. It's like a standard dry heat cell, but what we do is we add a sampling port on the side. So during the test, the cell is doing on the vertical position, but during the sampling, the cell tilts. So allow the sampling probe into the cell to take samples. That's a section of demonstration. So you can see the cell tilts, go to the sampling port, and the needle goes there, go into the port, take samples. After that, you will deposit into HPLC vial. We are using 1 ml sample syringe, so we can take very little sample, maybe 200 microliter or a little bit more. So we are able to do that. So this is the robotic system, dry heat robotic system we offer. So here we are, play again. So you tilt the cell, goes there, take the sample, and put into the vials. So this section is complete the dry heat system. The summary of the section 8, the dry heat system, was we are using the dry heat cell. So each cell have a serial number, and they're very easy to validate because they're loaded. And the design of the cell, they use a majority, they are Teflon. So it's not easy to break. And for the dry heat cell, there's no water. We don't need a water heater. We don't need a water circulator. And there's an air vent on the top of the cell. So when you fill the media from the bottom, we'll make sure there's no bubbles. And when you take the sample out from the cell, and the air allows to reduce the pressure, actually limit the pressure on the membrane to make sure there's no vacuum on the membrane, and we can take the cells. And there's a automated system, so there's a precision sampling anywhere from 0.5 ml to 10 mL. So this system is designed to a partial sample or the full media replacement. Okay, and this is a modular design. You can start with a very simple semi-automated system that go all the way to 24-cell system. All the tubing, this system is non-binding Teflon tubings, no cross-contamination. So the next section we are talking about is the water jacket system. So right now what you see is the standard water jacket system with a 45-degree sampling port. So we've been selling this system about maybe 30 years. We have a customer ask for different size, so we have a size chart. So people can use the cell, pick the part number from this chart, or if there's something they cannot use or they want something special, we will special design the cell for them. So with this design, we come out a low-cost console. This is water jacket system. So what we do is we build the heater, circulator, water tank, everything in one console. And the same console, there are 4 different attachments. You can use a 6-cell attachment, 12-cell attachment, a side-by-cell attachment, or side-by-cell and a vertical cell attachment. So one cell, you can do 4 things. And all the circulator, everything is built in. Okay, so the next version is, for the same version, we can use the cornea cell for the eye product, or use the nail cell for the fingernail products. Okay, that's a standard water jacket cell. So with time change, we also come out automated bubble-free cell, which is the design is like this. The water inlet and outlets on the side, we change the 45-degree sampling port to 2. One is the filling and the sampling port, which you put on the bottom, which are allowed to remove all the samples. And on top is the vent, so which allow, when you fill the media, will allow all the air bubble goes out. So here's the demo. You press the button, the cell tilts out. So in this demonstration, we'll only show one cell. So fill the media from the bottom, then you can see the air bubble goes out. So after you fill the cell, and then you can put the cover and then lower the head and then start the test. So for the temperature, we have a validation. So what we do is that here is the water tank. The water tank, the water actually go into the heater circulator, then pump into the cell water jacket. So what we do is that we verify the temperature. We make the cell temperature same as the water tank temperature. So during the test, all you have to do, so right now showing the water temperature, 37 degrees C. Now you put into the cell. Now you can see the cell temperature is at 37 degrees C. So during the test, there's no sensor in the cell. So what we do is you can take the temperature measurement from the water tank, then you will be the same temperature. So here we show again. Okay, for the same system, we automate it because we are using automated system to limit the human error. So you will give an exactly temperature, exactly sample value at the sample at the exactly time interval. So with the same system, we can build up up to 24 cell system. So on this slide, it shows the system is an electrode system. We use that to check the skin impedance. So there's a probe on top of the membrane and below the membrane. So before the test, we test the skin impedance. Then after test, we check the impedance again. So if there are difference, then we know that the skin may be break, or during the test or something happened to the skin. So that's a system we specially make for a customer, now become popular. So we offer this system to public. So summary, the water jacket system. The water jacket system is handmade, but because it's handmade, it's difficult to validate, but we're still able to calibrate the value to make each one is the same. But because it's a glass cell, it's very easy to break. So use a water jacket system, you need a water heater circulator. So the same design, we have an air vent to purge out the bubbles. And for the sampling, we are able to use a syringe pump. We're able to sample for anywhere from 0.5 ml to 10 ml. So the system can design to take a part of the sample or from the cell, or you remove all the media from the cell, do the full replacement. And the same thing, this is a modular design. It's very easy to upgrade. So all you have to do is call us. We can bring the syringe pump, bring the auto sampler to upgrade some automated system, become the fully automated system. So all the tubing we're using this one are the non-bonding Teflon tubings, no cross-contamination. So the last system we want to show is the flow-through system. I think earlier Jonathan explained to everyone very clearly about the flow-through system, and this, here we go, this is our system. What we did was that we designed the flow-through cell into a heater block. So what the heater block is a heater. When the media pass the flow-through cell, it's automatic heat up to 32 degrees. And this system, we are able to run with 8 channel, 16 channel, all the way up to 32 channel. Okay, so I think that's about all the equipment right now we're offering. So over here, I want to thank you, FDA, and all the people spend time to listen this workshop and listen my presentation. And I also want to thank you all the current and the past supporters that use Logan instruments. And we also always listen to the end user, their opinion, their feedback. We build a better equipment. We want to have more opportunity to work with FDA people. They are all the experts that we want to contribute better equipment for the people. Thank you, everybody.